Hello, my lovelies. It's Susanne, and today I want to show you how to solve this equation for x. If we take a look at our equation, we have log base 2 here. Our x is inside this logarithm, and here the same thing, log base 2, and our x is also in here. So to be able to solve for x, we have to get our x out of this logarithm, and same thing here, we have to get our x out of this logarithm as well. How can we do that? Well, there are some rules when we play with logarithms. For example, if you have a logarithm here and you subtract another logarithm, the important part is they have to have the same basis, what we have. Then there is a rule that tells us that we can write this here as one big logarithm, so not two separate ones, but we keep the base, and this is going to be one big logarithm. And inside, we're going to have a fraction. So because of this minus here, we know, or the rule tells us, then you're going to have a fraction inside your one big logarithm. And what we had in our first logarithm is what we're going to write down in the numerator here. And what we had in our second logarithm is what we're going to write down here in the denominator. And on the right side, we still have our 3. Okay, so instead of these two separate logarithms, we now only have this one big logarithm here. We still have the problem that our x is inside of this logarithm, so we still have to get our x out of here. So we have to get rid of this log base 2. How can we do that? Well, the base helps us. We have base 2 here. We can get rid of log base 2 by doing the following. We take the 2 and we do the following on both sides of the equation. We take 2 to the power of the entire left side, and here the same thing, 2 to the power of the entire right side, so here we only have 2 to the power of 3. The 2 to the power of log base 2 cancels this thing out, and the logarithm disappears, and only what is left inside of the logarithm is what is left on the left side. And on the right side, don't forget to do 2 to the power of 3, which equals 8. So our logarithm is gone, and this is how our equation looks like now. Okay, now we only have to solve this cute little equation. We have x here in the denominator, so to be able to solve for x, we have to get this x out of the denominator. So let's multiply both sides of the equation by this denominator. We write it in parentheses, so we multiply by 2 minus x here, and the same thing on the other side, so that here it cancels out and only x plus 1 is left. And on the other side, we can multiply here already, so 8 times 2 and 8 times minus x. 8 times 2 equals 16. 8 times negative x equals negative 8x. Okay, it's getting easier and easier. We want to solve for x. Maybe we bring the negative 8x to the left side by adding 8x on both sides of the equation, so that we have x plus 8x equals 9x. Don't forget the plus 1. And here we have the 16 because this cancels out. To solve for x, we want to get rid of the 1 here, so let's subtract it on both sides of the equation. Then we only have the 9x here. This cancels out. And on the other side, 16 minus 1 equals 15. To solve for x, let's get rid of the 9 here. So let's divide both sides by 9. this cancels out. X is left. And we have 15 over 9. But we can reduce this fraction a little bit more because both numbers are divisible by 3. So 15 over 3 equals 5. 9 over 3 equals 3. So in total, we have 5 over 3. We found a solution for our x, but we're not done yet because the problem is we have to check if this solution is really a valid solution for our equation. Because we're working with logarithms here, we have to make sure that if we insert our solution here for our x and here for our x, that what we have in the logarithm is greater than 0 here, and the same thing here. It has to be greater than 0. Then we have a valid solution. So we take our 5 over 3, insert it here, and after that also insert it here, and check if this here inside is greater than 0. Okay, let's check this. So for our x, we insert 5 over 3, and then we have the plus 1 here. Is this greater than 0? Yes, definitely. We have a positive number plus another positive number. This is positive, so greater than 0. We're good with this logarithm here. What about the second one? We have 2 minus, and for our x, we insert 5 over 3. Is this still greater than 0? Well, this time we should calculate this. So we can write the 2 as a fraction, 2 over 1. We need the same denominators. So let's multiply by 3 here. 1 times 3 equals 3. 2 times 3 equals 6. So we have 6 minus 5 equals 1. And the 3 stays the same. So yes, this is greater than 0. The world is good, and this is a valid solution. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of our next videos. Take care!